All right, for this problem, we're asked to find the extreme values of this function f of xy equals 6x squared plus 3y squared, subject to the constraint x squared plus y squared equals 1. All right, so first of all, we're going to define a new function here, g of xy, which is going to be equal to all of this equal to 0. So if we make this equal to 0, we get x squared plus y squared minus 1. And so we want g of x, y to be equal to 0. And we also need the gradient of f to be equal to the gradient of g times some constant lambda. So we're trying to find values for x, y, and lambda such that these two, the gradient of f is equal to the gradient of g times lambda, and g of x is equal to 0. All right, so first let's find the gradient of f and the gradient of g. The gradient of f is going to be the partial derivative of f with respect to x, which is going to be 12x times I, plus the partial derivative of f with respect to y, which is 6y, times j. All right, and then the gradient of g is going to be the partial derivative of g with respect to x, which is 2x times I, plus the partial derivative with respect to y, which is 2y times j. And now we want f to be equal to, or the gradient of f to be equal to the gradient of g times lambda. So 12x, it has got to be equal to 2x times lambda, just taking the I components for each of these, and the j components have to be equal as well. So 6y has got to be equal to 2y times lambda. Now notice that there's no lambda that we can plug in here that's going to work for both x and y unless either x is 0 or y is 0. Because if we were to solve lambda for x, if we divided both sides by 2x, we'd get that lambda is equal to 6. But if we plugged in 6 for lambda here, we'd get that 6y is equal to 12y, and that's not going to work. So the only way that this is going to work is if either x is 0 or y is 0. So those are the values that we need to check now. So if x is 0, let's go ahead and plug in 0 for x up here in g of xy is equal to 0. Remember we said that this has got to be true and g of xy has got to be equal to 0. So if we just go back up to this constraint here, if x is 0, then y squared has got to be equal to 1, so y is equal to plus or minus 1. And then similarly, if y is equal to 0, then x squared is equal to 1, so x is plus or minus 1. So now we have 4 points here. We've got the point 0 plus or minus 1. So 0, 1, and 0, negative 1 are 2 of the points. And then we've got plus or minus 1, 0. All right, so now we've got 4 points to check, and we can check each of those 4 points to see which one gives us a maximum, which one gives us a minimum. So let's try 0, 1 first. If we plugged in 0 and 1 into f of x, we get 0 here, so that'll go away, and then 1 squared is 1 times 3 is 3. And notice that same thing is going to happen if we plug in negative 1 for y, because negative 1 squared is also 1. So for either of these points, we're going to get a a value of 3 for f of xy. And over here, if we plug in 1 or negative 1 for x, that squared is going to be 1 times 6 plus 0 is going to be 6. And so we know that this is going to be our minimum, this is going to be our maximum. At either the point 0, 1 or 0, negative 1, we're going to have a minimum of 3. And at the point 1, 0 or negative 1, 0, we're going to have a maximum of 6.